We're going to start our study of solving trig equations today. So the first question says, determine whether theta equals pi over 4 is a solution of this equation. So let's plug it in. 2 sine. Notice how I'm going to plug in pi over 4 for theta. And we're going to see if this actually works. So 2 sine pi over 4, that would equal root 2 over 2. Minus 1 equals 0. Cancel. Root 2 minus 1 equals 0. That's not true. Therefore, pi over 4 is not a solution. So now we're wondering, what if theta equals pi over 6? So plug it in. 2 sine pi over 6 minus 1 equals 0. Sine pi over 6 is a half. Half times 2, that's 1. And look at that. 0 equals 0, that is true. Therefore, pi over 6 is a solution. So that's our starting point. Now let's see what happens, or how do we do it if we actually have to solve it. So let's try this. What I want you guys to do is draw a box around the sine theta. That's your variable for now. So I know we're solving for theta, but for now, focus on the sine theta. So we have 2 times the box plus root 3 equals 0. Let's solve for the box. I'm going to subtract root 3. So 2 times the box equals negative root 3. Divide by 2. So the box is negative root 3 over 2. Now let's plug it back in. We know the box is actually a function. That is sine theta. Once you're here, this is where you want to be. What you do is you think of it as our unit circle. So your work on your homework will look something like this. You think of the circle, and you think, where does sine theta equal negative root 3 over 2? Now you're probably thinking, well, that would be an infinite amount of places because the circle goes forever. That's why we're going to highlight right here. This tells you we're focusing on one rotation only. Okay, so one rotation, meaning theta should be between 0 and 2 pi. So now go back to our circle. Where is it negative root 3 over 2? That's the tick marks in quadrants 3 and 4 right there. So the answer is going to be 4 pi over 3 and 5 pi over 3. And that's it. We just solved our equation. Now let's try our next one. Again, notice that this restriction is there. This will be there for pretty much every problem because it has to tell you what the restriction would be. Otherwise, it'd be an infinite amount of answers. So this is one rotation again. So I'll just note that for you. Notice how it's cosine squared theta. So we're going to solve it by, of course, doing the square root. Now here's the part that's very important to understand. I'll put a note on the side. Note. If you have x squared equals 4, when you solve this, the root of 4 is positive 2. The root of x squared is the absolute value of x. That's very important to understand. I need you guys to write that in your homework, your notes, your tests. I will mark you wrong if you do not show this step, because this is how it actually works. And that means x is plus or minus 2. So again, if you do not write the absolute value, I will mark it wrong. And this will be the root of a half, which is root 2 over 2. And then you get cosine theta equals plus or minus root 2 over 2. And there you go. We just solve it. Think of your circle. That's going to be all the 45-degree answers. So theta is going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I know a lot of you are very comfortable with degrees, but notice how radians is actually pretty easy because all the denominators are going to match. So you'll find that radians actually isn't that bad in solving. Now again, I need you guys to really highlight this step You will need this. And that's because I need you guys to understand that this part over here, this is the part people often get confused, that the root of 4 is only 2. The root of 4 is not plus or minus 2. The root function only generates a positive answer. The root of 4 equals positive 2. So that's why you need the absolute value step, and I'm going to check that as we're working today. Okay, 2 more examples and we're done. Now if you look at this one, notice how it's still our theta to 2 pi, which means we're considering 0 to 360. However, there's something really interesting here. There's a 2 theta. So that actually makes it a little more complicated. What that actually tells you is it's going to speed up the function, meaning the function is going to go faster. So what I want you to do is you think of that as basically saying twice around the circle. So to solve this, what we're going to do is draw 2 circles. 1, 2. We're going to mark everywhere where sine is equal to a half. So just to be clear, in the first rotation we have those 2, and the second rotation we have these 2, which means we have a total of 4 answers. Now here's the important part. What we're going to solve for now is this 2 theta. So we're grabbing 2 theta, and that's going to equal the 4 answers we just found. Okay, so the first one, that would be pi over 6. The next one is 5 pi over 6. Now if you go one more rotation, all we're going to do is add 2 pi. So imagine you just add 2 pi to both of these. The next answer right below it, that's going to be 13 pi over 6. The next one's going to be 17 pi over 6. And again, that's just adding a full rotation. Okay, so I'll get rid of this now. Now you're probably wondering, how can those answers be right? Because we said right here, theta has to be between 0 and 2 pi. And you're right, theta has to be between 0 and 2 pi. That's because look at what we solved for. We solved for 2 theta, which means we're going to take all these answers, multiply it by 1 over 2, and that solves for theta. So the answers are actually pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And notice how all of those answers are between 0 and 2 pi. So I'll box that. There's our answers. Now if you're wondering how these answers work, remember there's a 2 theta in, so when you plug it in, I'll pick one that's weird. Let's say 5 pi over 12. Sine of 2, if you're to plug in 5 pi over 12, that reduces to 5 pi over 6. Oh. And notice how that does equal a half, so that does check out. And that works for all of them. Let's go to the next one. So remember the 2 theta meant twice from the circle? So theta over 2, again, let's highlight this and this. Theta over 2 must mean half the circle. So to start, we're going to draw half a circle. Let's mark where sine hits a half, so that's going to be right here and here. And the process is the exact same thing. We're going to first focus on what's actually in the function. We're going to solve for theta over 2, and that is equal to the 2 answers we just found, which would be pi over 6 and 5 pi over 6. Now we think, is that the answer? No, because we just solved for theta over 2. We have to solve for theta, so to do that, we're going to multiply it by 2, so theta must be pi over 3 and 5 pi over 3.
Now you're going to work on the next part of the worksheet and continue the video once you finish the next page of problems. This is the second part of the video, and what we're going to do next is study what it means to have a general solution.
This is like everything we've been doing. Cosine theta equals a half, but notice how there is no restriction, right? There's no restriction here. which means that we actually got to find every possible answer. So that's why it says give a general formula for all the solutions, meaning we want to find every answer. Now the book will say list 6 solutions. You can cross that out. We're just going to do 4. And you can do the same thing on your homework. So to do this, we're going to do the exact same thing we did earlier. Let's figure this out using our circle. So there's our circle. 1/2, we think, okay, where's cosine 1/2? We're going to mark that. That's in quadrant 1 at the top, quadrant 4 at the bottom. Now here's what we do. We're going to write theta is equal to, the first angle is pi over 3. The second angle is 5 pi over 3. And notice how that's only 2 answers. That's only 1 rotation. So to make it for every possible rotation, we're going to put a big bracket and put plus 2 pi k. And now that covers every single rotation, meaning this is theoretically every answer possible. So in our notes, we're going to box this and label it. This represents all possible answers. Now to generate possible solutions, basically just plug in numbers for k. So let's say k equals 0, meaning you just want your regular ones. So theta could equal pi over 3, theta could equal 5 pi over 3, and then just add 2 pi to each of those to get the next answers. So 7 pi over 3 and 11 pi over 3. Okay, we're going to box that. Now what this box is for possible answers. And now we're done. So your homework will have you do those 2 things as well, and make sure you label them appropriately. Second example. Solve the equation sine of 2 theta equals 1/2. So again, notice there is no restriction. That's important. In our classwork last class, we just drew 2 circles. And this one, there's actually no need to, because we're going to find every solution anyway. So do the exact same thing we just did. Here's our circle. Just got to think, where does sine hit 1/2? So that's going to be these 2 tick marks right there. And then similar to last class, you're going to grab that 2 theta piece. We're going to say, well, 2 theta should equal where sine is 1/2. That's going to be pi over 6 and 5 pi over 6. And again, that's 2 possible answers. So to cover everything, simply put plus 2 pi k. Now at this point you think, is that every possible solution? The answer is yes, if we're solving for 2 theta. We just want to solve for this theta. So let's multiply this whole thing by 1/2 to get rid of that 2. So notice how these will cancel. So now we have theta is equal to, now be careful when you multiply. We multiply by 1/2 here, you're going to get pi over 12, 5 pi over 12. And this is the part people often make a mistake. The 1/2 hits everything, so this now becomes pi k. Okay, we're going to box this. Label. This represents all possible answers. Now we're halfway done. Again, the book will say list 6. Just do 4. You can do 6 if you want, but for me 4 is enough. Use the 2 given already. Pi over 12, 5 pi over 12. Now for this time, the solution over here, or the first one we found, said plus pi k. So just add pi to both of them. So that's 13 pi over 12. And the next one would be 17 pi over 12. Okay, we're going to box this. Okay, that's good enough. And this is going to be our 4 possible answers. Last example. Tan theta over 2 equals root 3. Again, notice there are no restrictions, which means we're going to find every possible answer. So when we look at this, same technique. Draw a circle. Where does tan hit root 3? So that's going to be quadrant 1 at the top, quadrant 3 at the bottom. Grab that piece right there. So we just solve for theta over 2. Those are pi over 3 and 4 pi over 3, big bracket, plus 2 pi k to cover every situation. Now we solve for theta, so multiply this whole thing by 2, since you want to get rid of the over 2. So theta should equal 2 pi over 3, comma 8 pi over 3, plus 4 pi k. I'm going to box this. And again, this represents all possible answers. Let's find 4 possible. So theta could equal 2 pi over 3, 8 pi over 3. We just add 4 pi to each of these. So that would be 14 pi over 3. And the last one, let's add 12 to that. So that's 20 pi over 3. We'll box that. I know it's repetitive, but it's important to understand this. So this, again, is going to be 4 possible answers. Now, there is a separate situation for tan. So that's why I left room here. Or tan has a special case. Because the period of tan is shorter, meaning if you look at the circle we made earlier, notice how these two things over here, I'm really going to zoom in on this. Notice how these two things over here are exactly 180 apart, or pi apart. So because tan has a special property, we can actually make the answer a little bit shorter. We could actually just say theta over 2 is equal to pi over 3, one bracket, plus pi k. And then multiply this by 2. So theta would be 2 pi over 3 plus 2 pi k. And we could actually use that. But again, this is optional. This is more just for people who are noticing that tan, you could do a little trick to make it faster. But notice how those two answers are the same. Now, the only thing to add before I wrap this video up is some people refer to this thing, this whole problem we're doing, as the general solution. Okay, so you want to make sure, it says the general formula over here. Many books and many tests, many teachers will sometimes say general solution. So you just have to know that's what that means. General solution meaning find everything. So I'll write that one more time for you. General solution. So if you see that on a test or quiz, that's what that would mean. General solution means all possible answers. For these next two questions, I'm going to show you how to solve any trig equation using your calculator. So first, notice the equation. It's tan theta equals -2. Also notice this piece right here, that theta is in this interval 0 to 2 pi. That's very important. So to approximate, I'm just going to write 0 to about 6.28. Our answer should be within that range. Now the easiest way to approach any of these is to do this. Make your equation equal 0. Okay, so make sure you guys all highlight that. That's what you want to do. So for this one, let's manipulate it. We're going to write tan theta plus 2 equals 0. This is what you graph. We're going to graph this function y equals tan theta plus 2. So I'm going to go to my calculator. Tan theta, or x, plus 2. Before you graph, make sure you tap the right corner. Make sure you're in radians, or if you're in degrees, that graph will be pretty weird. So make sure you hit radians. I'm going to graph, and here we see a whole bunch of lines. Right? That's our tan graph over and over again. So I'm just going to do a quick copy of that. Now we're going to find the root. So you're going to hit function and root, and hit this arrow so you can see what root we're talking about. So notice how there are infinite answers here, but we don't want this one. We want the ones that are going to be between 0 and 6. So tap near this first one, function root. So 2.034. Let's get the next one, 5.176. And let's go one more, 8.31. So that's too big. So now we have our answers. So let's go back to the worksheet. So let's notate these. Here's the first one. That one was 2.034. There's the next one. That one is 5.176. So we're going to write theta should equal 2.034 and 5.176. And there are our answers for this equation. So let's try one more. 5 sine x plus x equals 3. So let's manipulate that. That's going to be 5 sine x plus x minus 3 equals 0. We're going to use our graphing calculator, and then we're going to find the roots. Okay, so that's going to be our typical method. Let's go back to our calculator. You can clear this. The equation was 5 sine x plus x minus 3. We're going to graph it. And there we have our graph. I'm just going to take a screenshot and move it over. Now let's analyze the graph. Menu, function, root. I'm going to hit my plus sign so I can see it clearly. So I got 0.519. That's my first one. Let's check the next one. 3.177. Okay, that looks good. Let's get one more. 5.71. All right, so those all work. So we'll go back to our worksheet. I already put it in there, so now we can just notate. Let's circle these three. That first one was 0.519. The next one was 3.177. And that last one was 5.71. So we're going to write our answers that x is equal to 0.519, 3.177, and 5.71. And that's how you use your calculator.